Hello and welcome back to this channel. This is Professor Rajesh Barapate, a book author of 25 plus engineering books. Dear students, today's topic is circular convolution. It is the convolution in the field of Fourier transformation, rather DFT. So without wasting the time, let us dive into the topic. If we have two sequences x of n and h of n, its circular convolution is denoted by this notation. You will have to draw one circle and write n inside it. It is also referred as n point circular convolution, capital N point circular convolution. For example, if in the sequence of x of n there are 4 samples and in the sequence of h of n also there are 4 samples, then value of n will be 4, so it is called as 4-point circular convolution. The mathematical equation to calculate the circular convolution is y of m. This m is the notation used to represent circular convolution. Is summation n 0 to n minus 1 x of n h of double bracket m minus n. What this sign indicates? Double bracket indicates that you need to plot the sequences in a circular fashion. I will tell you how to plot the sequence in circular fashion. Presently we are just discussing the mathematical equation. Now, before solving the numerical, let me tell you how to plot the sequences circularly. Suppose I have the sequence x of n, which is 1, 2, 3, 4. Now, by default, if arrow is not mentioned, it is at first position. How to plot the samples in circular fashion? Draw the circle. If you are plotting the samples circularly, it is denoted by x of double bracket n. Double bracket indicates you are plotting the samples in a circular fashion. Now, how to plot the different samples? As a convention, this point is taken as a starting point. In case of x of n, plot all the samples in anti-clockwise direction like this. How many samples are there? There are 4 samples, so I will take this as a starting point and I will mark all the samples in anti-clockwise direction. Anti-clockwise means this direction. This is the way how you can plot the sequence x of n. There are 4 samples, so I have divided the circle into 4 parts. If there are 8 samples, I would have divided the circle into 8 parts and so on. Now, one more variation is there, that is x of double bracket minus n. It is called as a folded sequence. X of double bracket minus n is called as a folded sequence. What we learned in the previous case, if sequence is x of n, take this as a starting point and mark the samples in anti-clockwise direction. If it is a folded sequence, as a convention, this same point, which is similar to the previous case, is a starting point. But in this case, mark samples in clockwise direction. Clockwise means like this. So this is the starting point. I will mark the samples like this. 1, 2, 3, 4. Now, one more variation which is required for solving the numericals. If I write x of double bracket n minus 1, it indicates delay of this sequence by 1 position. Remember simple rules. What I said, for plotting x of n, take this as a starting point, mark samples in anti-clockwise direction. If sequence is folded, take this as a starting point, mark samples in clockwise direction. If you are having the equation x of double bracket n minus 1, it indicates delay. Now remember this rule. If you want to perform delay, delay means shift anti-clockwise. Delay means shift anti-clockwise. So, it is x of n minus 1, that means delay by 1 position. So I need to shift every sample of x of n in anti-clockwise direction. So how to do it? See, I will draw the new circle to show the folded version. Originally, this was the starting point. I want to shift every sample in anti-clockwise direction. So this starting point will be at this position. So new samples can be written like this. This is 1, then 2, 3, 4. Very simple. What I did, I have rotated every sample in anti-clockwise direction. So remember this rule, delay means rotate anti-clockwise. If it is delay by 1, rotate each sample in anti-clockwise direction. Now let us solve the numerical so that you will get the idea to how to make use of this mathematical equation. We'll solve one numerical. Question is, obtain circular convolution of two sequences are given. X of n is 1, 2, 3, 4. H of n is 2, 1, 2, 1. By default, arrow will be at first position. Now, there are different methods for the calculation of circular convolution. In today's video, I will explain you two methods. One is graphical method, second is matrix method. If in the question name of method is not mentioned, you are allowed to make use of any method. But if the name of method is mentioned, you need to strictly follow that method. So first we will be talking about a graphical method. As the name indicates, you need to draw the graphs. In this case, it is not graph as such. You need to draw the diagram and then do the calculation. This is also called as concentric circle method. Now how to do it? You need to draw two circles. First calculation, see. We know that result of circular convolution is denoted by y of m. The range of m in this case is 0 to n minus 1. What about n? N represents number of points contained in the sequence x of n and h of n. Very simple rule. Suppose the given sequence x of n is 1, 2, 3, 4 and h of n contains only 3 samples. We have learned it in earlier videos. If the number of samples are different, then to adjust the length, you need to add zeros. So I would have added 0 over here to make its length same as x of n. Presently, there are 4 samples in each sequence. Now, result of circular convolution is y of m, range of m is 0 to n minus 1. N means number of samples contained in each sequence. So value of capital N in this case is 4. That means range of m will be 0 to 3. So first calculation, I will be doing calculation of y of 0. As I said, we are studying the graphical method, which is also known as concentric circle method. First, we need to draw one circle. This is the circle of x of n. This is the circle of x of n. As we discussed earlier, this is the starting point. Mark all the samples in anti-clockwise direction. So the sequence is 1, 2, 3, 4. This is the sequence of x of n, which is 1, 2, 3, 4. This is starting point and we have marked the samples in anti-clockwise direction. Outside this, I need to draw the circle of h. So I will draw one more circle outside this. Take this as a starting point. Now listen carefully. For circle of x of n, I have plotted the samples in anti-clockwise direction. Whereas in the first step, for h of n, plot the samples in clockwise direction. Plot the samples in clockwise direction. By default, this will be starting point. So clockwise means along this direction. So the sequence x of n is 2, 1, 2, 1. So this is starting point 2, 1, 2, 1. That's it. Now, remember this rule. Listen carefully. First circle is x of n, inner circle. All the samples are plotted in anti-clockwise direction. Outer circle is circle for h of n. Take this as a starting point and plot the samples in clockwise direction. Clockwise direction. Now, consider nearby elements. For example, this is 2 and this element is 1. Take multiplication of nearby elements. So it is 2 into 1. This gives me answer 2. Similarly, this is 1 into 2. This gives me answer 2. I'm taking simple multiplication of nearby elements. 4 into 1. This gives me 4. 3 into 2. This gives me 6. Whatever results of multiplication you got, just add those results. So 2 plus 2, 4 plus 4, 8. 8 plus 6, 14. So first answer is 14. So I will write answer of y of 0 is 1, 4. This is the first answer. First step is very much important because entire remaining numerical depends on this step. In the second step, what I need to do every time, keep the inner circle as it is. Now, I will draw the new diagram. I am doing calculation for y of 1. So, inner diagram, I will keep it as it is like this. This is the circle for x of n. every time starting point is this, and for x of n, mark samples in anti-clockwise direction. In all throughout the calculation, x of n is plotted like this in anti-clockwise direction, in this direction only. Outside this, draw the circle of h, but now I will explain you how to mark the samples. This calculation I am doing it for next, that means for y of n. This was the earlier diagram. Every time keep inner circle as it is, rotate outer circle. Outer circle is for h of n, which we have plotted clockwise. Now forget it. Rotate outer circle every time by one position in anti-clockwise direction. See, in the first step, x of n is anti-clockwise, h of n is clockwise. After that, every time keep x of n as it is, rotate h of n in anti-clockwise direction by one position. Keep in mind, when we say h of n, all the samples of h of n must be plotted in clockwise direction. So what I said, rotate outer circle by one position in anti-clockwise direction. So this was the starting point. Now starting point will be here. So this will be the starting point. But this is the outer circle. That means circle of h of n. So we need to plot the samples in clockwise direction. Just rotate the starting point. Then after that, plot the samples in clockwise direction. So samples are 2, 1, 2, 1. I have just rotated. This was starting point in the earlier case. Now starting point is rotated in an anti-clockwise direction. But plot the samples in clockwise because this is the outer circle. So it becomes 2, 1, 2, 1. Remaining procedure is same. Take multiplication of nearby elements. So this is 2 into 2, 4. This is 1 into 1, 1. This is 4 into 2, 8. This is 1 into 3, 3. So new answer will be 4 plus 1, 5. 5 plus 8, 13. 13 plus 3, 16. So y of 1 is 16. Now, this we did it for y of 0 and y of 1. Next calculation. Next calculation is y of 2. For y of 2, refer case of y of 1. For y of 1, what we did? We referred diagram for y of 0. Likewise, every time, go on referring the previous diagram. So for y of 2, I will be referring diagram of y of 1. That is this diagram. In all cases, as I said earlier, inner circle remains as it is. So 1, 2, 3, 4. For outer circle, every time, rotate outer circle in anti-clockwise direction. Now this was the starting point. So starting point will be here. And I have rotated it in anti-clockwise direction by one position. But this is the outer circle, so mark all the samples in clockwise direction. Very simple, just rotate the starting position. After that, mark samples in clockwise direction for outer circle. So this is the starting point, new starting point. So it is 2, 1, 2, 1. Remaining procedure is same. Take multiplication of nearby elements. So this becomes 2 into 1, 2. Then 1 into 2, 2. Then 4 into 1, 4. Then 3 into 2, 6. Again, add all these results of multiplication. So it becomes 4 plus 4, 8. 8 plus 6, that is 14. So answer of y of 2 is 14. Next calculation. Next calculation is the calculation of y of 3. Every time, refer the previous diagram. So if I am doing calculation for y of 3, I need to refer the diagram which we had drawn for y of 2. So, like the previous case, inner circle remains as it is. I will draw it first. This circle of x of n. Starting point is this. 1, 2, 3, 4. Important part is outer circle. So, first I will draw the outer circle. This circle is for h of n. Now, in the previous case, for y of 3, previous case means y of 2. In the previous case, this was the starting point. Rotate starting point in anti-clockwise direction. That means in this direction. So, starting point will be here. That is 2. After that, since it is outer circle, mark samples in clockwise direction. So, samples will be 2, 1, 2, 1. Remaining procedure is same like the previous case. Take multiplication of nearby elements. So I will get 2 into 2, 4, then 1 into 1, 1, then 4 into 2, 8, 3 into 1, 3. Add the results of multiplication. So it is 4 plus 1, 5, 5 plus 8, 13 plus 3, 16. So final answer is 16. Up to which value of m? That means I did it up to y of 3. Up to which value of m you need to do? Very simple. There were 4 samples. That means value of n was 4. So just perform 4 calculations. Y of 0, y of 1, y of 2, y of 3. That's it. Now, final answer is written as a sequence. We did all the calculations. As I said, this is called as a graphical method or concentric circle method. Now, after completion of all the calculations, what do you need to do? Write the result of convolution in the form of sequence. That means final answer is y of m is equals to, first answer was 14, next was 16, next was 14, and last was 16. This is the final answer, what we got from the graphical method. Dear students, this is somewhat lengthy method. So as I said, if the concentric circle method or graphical method is mentioned, then and then only follow this method. There is one simple method which is called as the matrix method. We'll solve the same numerical so that you can cross check the answer. What we did in the graphical method, every time we kept circle of x of n constant as it is. Initially we had drawn the samples of x of n in anticlockwise direction. After that, every time that circle is kept constant, and we rotated circle of h of n every time for every calculation. Now, in matrix method, directly you can do the calculation. How many samples are there? There are 4 samples. So, final answer, I will write it in the matrix form like this: y of 0, y of 1, y of 2, y of 3 is equals to which sequence we have rotated? We rotated the sequence of h of n. So initially, draw sequence h of n as a column matrix. I will write it like this: 2, 1, 2, 1. What I did? I wrote the equation of output in terms of column matrix. Then I chose the sequence x of n. It is written as a column. As we discussed, we have rotated sequence of h of n. So rotate this one, bring it at first position like this here. So this one which was in the last position will be at first position. So new sequence will be, this will be 1. What I did, this one I brought it at the first position. So because of this, every sample will be shifted downward. So this 2 will be here, this one will be here, this 2 will be here. Very simple. What I did, I wrote h of n as a column. After that, I have shifted this at the first position. Indirectly, I have rotated it like this. So after that, 1 will be at top position. Every sample will be shifted downward. Again, rotate it by 1 position. So again, this 2 sample will be brought at the beginning like this. So this sample will be 2. What I did, I have changed this and I brought it at the starting position. So every sample will be shifted downward. So it is, this 1 will be here, this 2 will be here, 1 will be here, like this. Again, rotate it by 1 position. So this last one will now be at the top position. Then every sample will be shifted downward. So this 2 will be here, this 1 will be here, this 2 will be here, like this. What should be the size of matrix? Very simple. There are 4 samples. So size of matrix should be 4 by 4. That means 4 rows and 4 columns. So this is the matrix H of n. After that, write matrix X of n as a column matrix, which is as it is. Now simply you have to take matrix multiplication. I hope you are aware how to perform matrix multiplication. Those who have forgotten, consider this row and this column. Multiply individual elements. That is 2 into 1. It becomes 2, then 1 into 2. Plus 2, then 2 into 3. Plus 6, then 1 into 4. Plus 4. Then consider second row, same column. So 1 into 1, 1, 2 into 2, 4. 1 into 3, 3. 2 into 4, 8. Then third row, same column. 2 into 1, 2. Plus 1 into 2, 2. 2 into 3, 6. 1 into 4, 4. Then last row, same column. 1 into 1, 1 plus 4 plus 3 plus 8. Directly you can write the answer from this. So it is 14, then 16, 14 and 16. Same answer we got using this method. This is called as the matrix method. Like the previous case, final answer is written as a sequence. So it is 14, 16, 14 and 16. So this is the simplest method. One more important thing. I have rotated the sequence h of n and I generated the matrix of h of n, which is having 4 rows and 4 columns. Instead of that, you may keep h of n constant and generate the matrix from x of n. You will get the same answer. This is called as the matrix method. What are the possible variations from the exam point of view? As I mentioned earlier, one sequence contains 4 samples. If another contains only 3 samples or 2 samples, whatever, go on adding zeros at the end, which is called as zero padding, so that you will get the length of each sequence same. This is one possible variation. There are 4 samples given in the present question. The number of samples can be different, like it can be 3, it can be 5, it can be 8. Depending on that, you will divide the circle into number of parts, but the basic procedure remains same. I hope you might have understood this concept. So thanks for watching this video. That's it for today's video. Thank you very much.